Okay, so this is a question about a harder quadratic. I've got this path shown here, and the situation is that this person is standing on a platform here, and he's got a gas powered cannon, and he fires t-shirts out of it, and it reaches its peak at 7 meters from where he starts, and it would have landed at 28 meters, but then some girl caught it at 25 meters, who was 1 meter 755 tall. My x-axis is in meters, my y-axis is in centimeters. That's all there. I've got to find the equation of this graph. Now, on the surface of it, it looks quite tough, because you would immediately assume that you're going to do this by completing the square. But I've only got one value. And then you look at it and you go, well, actually, I've only got one root as well, so I can't do it by factorising. But you can, because we all know that graphs are symmetrical around about their turning point. So the distance from 7 to 28 is 21. So the distance from 7 to the other root is also 21. So therefore 7 minus 21 is 14. So this bit of the graph will hit the ground at 14 meters behind the axis. And at that point I can work out this equation. So I know that there's going to be a scalar. I know that one value is 14, and because it's on the left hand side of the equals, it's going to be a plus 14. I know the other value is 28. At this point I use my point, my 25, and I've got to remember that that's in meters and my y-axis is in centimeters, so that is 175.5 equals k, and then I've got 25 plus 14 and 25 minus 28. So if I look at that, 25 plus 14 is 39, and 25 minus 28 is minus 3, and I've still got the k, and that's got to equal 175.5. Well, 39 times minus 3 is minus 117. So I've got 175.5 equals minus 117k, so k must equal minus 175.5 divided by 117, and that happens to equal 1.5. So I've now managed to work out the equation, which is y equals minus, because it's a minus, 1.5 x plus 14 x minus 28. Okay, so that's my equation for this graph. So that's the first bit. Oops, that bit. The second bit is find the equation if Bob fired in the opposite direction. Well, if everything else remained the same, instantly I know that the new landing point on this side would have been 14. My graph's going to go through there and it's going to land at 28. So the only bits of this equation that are going to change are the roots. Done.